Okay, good afternoon, everybody. So my name's Scott James Remnant. I've met a few of you before, I'm sure, but I'm going to be talking today about Upstart, which is a sort of personal project of mine and one that Canonical has been sponsoring for Ubuntu. More particularly, I'm going to be talking about the roadmap to Upstart 1.0, which is going to be the next major version, I hope. So just want to start off by talking a little bit about the purpose of Upstart, and then talk about a little bit of its history. There's a lot of common misconception about why we did Upstart. The first one of those is that we did it because of boot performance, and there's a sort of, with some of the recent push towards the 5-second boot and so on, is sort of, well, Upstart doesn't help that. Well, that's true, because that's never been one of the purposes of Upstart. So I kind of want to sort of go a little bit over again why we did it. One of the first and obvious things Upstart is designed to do, it provides a true service manager. We don't have one at the moment in Linux. If you go and boot up Solaris, you'll find you've got Solaris SMF in there, which gives you a true service manager. If you look at Apple, they even have LaunchD. If you look at Windows, obviously Windows has its very well sort of stabilized and service manager in there, but we don't have one at all. In fact, if you look at your Linux bots, you'll see that what you think of as services are actually just shell scripts that do a bunch of commands to try and start a particular process. And when you want to stop it, there's shell scripts that go and try and find that process in the process list and then try and kill it. It's not really doing service management at all. We recently added the status command to a lot of our init scripts in Ubuntu. And we found that to do this, we had to edit every single init script. We had to add a status command to every single init script. And that status command was different for just about every single init script because different processes could be found differently. So there's no sort of service manager. And what I mean by service manager is just sort of what you can probably 4 basic commands. You should be able to start a service. You should be able to stop a service. You should be able to restart a service, obviously, and restart's not quite the same as stop and start because restart has to be atomic. When the restart finishes, it should be started again. And then status, you should be able to see the status of a running service. You should be able to say, is Squid running? It should be able to tell you yes. It should be able to tell you, its process ID and various things like that. So that's sort of one of the first goals, provide something we don't have today. Well, kind of. Ironically, the sys5 init daemon kind of has some of these functionality, but we don't use it in Linux, probably because it's quite hard to do. Another kind of main goal of Upstart was actually to provide an API for other processes to communicate with the init daemon. It's all very well and good having a service manager, but if your service manager kind of keeps itself to itself and doesn't really talk to the rest of the system, then it's not really that useful. So one of the main goals of Upstart again was not only does it provide the service management commands, it actually provides them in a way that other processes can access those commands without having to just fork and execute, the start command on disk and parse its output. The earliest versions of Upstart used a private API for this. The later versions of Upstart just simply use dbus. So you can communicate with the service manager over dbus. And particularly, you've got sort of various commands. You can tell Upstart to get a job by the name, so you can say, give me the Apache service, give me the Squid service. You can list all the jobs. This is only a small list of commands. Obviously, you can start a job, and you can stop a job, and you can restart a job, and query its status, and so on from the dbus interface. And most usefully, of course, you can create a job from the dbus interface. One of the things Upstart doesn't require that the configuration is on the disk. So if you want to just create a service and have it maintained by the service manager, you can provide all the details of that service over the dbus interface and start and stop it and so on. But particularly, for example, if you need a long-running FSOC or a long-running monitoring service, you can use Upstart to actually manage that for you, so you don't have to worry about the details of it, the details of service management. And also, this is kind of where the confusion comes from. Why we kind of talk about, when we're talking about boot performance work, we always talk about Upstart in boot performance work, but that doesn't mean Upstart itself makes your boot faster. What Upstart instead does is many of the primitives it provides, and by providing a true service manager, it allows you to eliminate busy loops, sleep loops, wake, race conditions, and so on from your boot process. Typically, example for this kind of thing is that we have in our boot sequence a loop which waits for the root file system device node to appear on disk, and then another loop after that which actually waits for that device node to be set up. Because if that device node is LVM and RAID and so on, we actually need to keep spinning until the RAID is actually activated. With Upstart, the idea is that you can, by doing these things as services, by managing the tasks, you can get notification that it's complete. You can, you have an atomic status notification, and you can sort of chain things off each other, and services can chain off each other. So, you can effectively eliminate all the sleep statements, all the busy loops, and so on at your boot sequence. And by stating what the requirements of a particular service are, you can get rid of race conditions, which nobody likes race conditions. And the other point about Upstart, which is wasn't quite in its original design, but that's because it didn't really exist in its original design, is Upstart's intending to be a part of what we call the plumbing layer, which is quite day-glow and colourful here. And I do apologise because I'm sure that there are areas of the plumbing layer which have been missed out of this graph. But this is kind of the stack that I need to bring up an X server and use the desktop session right now on this laptop. So, plumbing layer, it's a sort of new term. The first time I really heard this term being used was last year. So, Upstart's kind of 2 and a bit years old now. So, we're that's why it's not really part of its original design. The plumbing layer is something that's only really been described as a single group of processes in the last year or so. You start off, the kernel's beneath the plumbing layer, your desktop session's above the plumbing layer. It's all of the individual pieces that allow you to kind of have a desktop running as an ordinary user, while system hardware and so is being controlled by privileged processors. So you have UDEV sitting, talks to the kernel, receives notification of changes to the hardware and changes to the system state from the kernel. UDEV feeds this information into HAL or device kit. I don't think David's with us here, but if he was, you could ask him about device kit. It's a replacement for HAL coming in the next couple of years. Those talk and announce and provide services and objects for pieces of hardware on your machine over dbus, which allows sort of various system daemons to talk over dbus as well and sort of provide service information. Avahi provides information about services available on the network, so printers, other machines, SSH servers, HTTP servers, iTunes, and so on over the network. Network Managers obviously uses the hardware information from HAL to gain networking information, bring up network cards, set those up. Pulse Audio allows you to manage multiple sound cards, multiple channels on those sound cards, and allow multiple applications to talk to them. So it's a sort of sound mixer, but one that has awareness of multiplicity in both directions. These use the console kit and policy kit libraries to do authorization, and allows us to worry about systems which have multiple seats or even multiple CPUs. So we can deal with systems that have 5 consoles, each of which has 3 keyboards and mice and so on. And that we actually know then when a USB stick is plugged in, which seat of which console of which seat the USB stick was plugged into, and can actually provide authorization only for the user logged in at that seat. And all of these services are aware of it. And Upstart naturally fits into this plumbing layer. In particular, the point, I went really loud there for a second. In particular, the point at which Upstart appears, hang on, I have the worst clicker in the world, sorry. There, okay. And the point at which Upstart kind of appears is alongside the lot. It's sort of, its job, it doesn't really it doesn't provide services, it doesn't provide the sort of networking, it doesn't provide hardware, but what it does do is keep the rest of the system running. So Upstart would be supervising the UDEV daemon, making sure it's working, supervising HAL or device kit, supervising the dbus daemon, supervising the other sort of policy daemons. And in effect, it actually kind of does. In fact, it's communicating over dbus, so provides a plumbing layer service for services. So you can use it to start and stop services on demand. One of the areas this kind of comes in useful is you can start doing things like having plumbing layer components, like the Bluetooth stack, only started if you've got a Bluetooth device and so on. So it fits in with this lot somewhere alongside the lot of it. Okay, I'll talk. Right. So that's kind of what Upstart's for and where it fits into the ecosystem at the moment. So I just want to give a little bit of a talk over the history of Upstart up until this point. I'm going to just enter, I think. So the first version of Upstart came out in August 2006. So that's 2 and a bit years ago now. In fact, it kind of never really came out. We didn't put the sort of the packages many places and never went into a release. It was actually developed at the Ubuntu developer sprint in Wiesbaden, I think it was prior to Linuxtag or just after Linuxtag. It was quite simple in the terms of jobs. Jobs themselves you couldn't define a service by much more than sort of a command to run and maybe some scripts to tear it up and tear it down. But the events part of it is quite complicated. It was actually turned out to be far too complicated at the time, and it maintained a history of events and so on. And it kind of had a sort of syntax which kind of would be altered by today's standards. Well, the version we actually first really released in Ubuntu was in Ubuntu 6.10, and that was 0.27. The event system was vastly simplified. So the event system is kind of the core of Upstart, one of the cores of Upstart. You have a service manager which can sorry. You have a service manager which can start and stop and so on your jobs, and you have an event system that can automatically start and stop jobs. So that you can start and stop jobs on events. The events are generated by hardware on your machine, by software on your machine, and thus you can build up a sort of a service management and a mesh of services which communicate with each other as well as with the rest of the system and start and stop themselves. And the IPC, the actual communication with Upstart, was very homebrewed. It was a Unix domain socket, and you talked to it, and you had various messages you expected to pass. And it was kind of never really adopted. It was very odd and arcane and very much designed for the init control process which comes with Upstart, and it turned out to be quite difficult. We tried writing a simple GTK front end, and it turned out that the asynchronous and sort of out-of-order messages it tended to deliver were really not suitable for a graphical program, which was also expected to be out of order and asynchronous. But Upstart 0.2 was probably the first version that got the start-on, stop-on syntax that Upstart still carries to this day. The major milestone in Upstart's of early development would be the 0.3 series. 0.38 was in Ubuntu 7.04 and 7.10, and 0.39, which was in Ubuntu 8.04 and Ubuntu 8.10, the last two releases, and also in Fedora 10 and 11. I think it was Fedora 10 that it first went in, and Fedora 11 is obviously the next release, which is in alpha now. This is the sort of very stable version of Upstart. It was intended for distributions to be able to deploy and test out and experiment with. One of the kind of key things about it is that it kind of completely backwardsly emulates sys5init, the actual sys5init daemon, not the scripts. But by doing that, it can run the script, the actual sys5rc script, just as well as the system5 daemon can. This has allowed us to deploy it, keep it deployed for a couple of years, making small changes to the code, making experiments. We have experimental kind of complete Upstart-based boots and so on, without actually worrying about having to have a flag day. At no point in its development do we need a flag day to say, this is the day where everything switches to Upstart. We can always keep support for init scripts around forever. We just would gradually phase them out over time. So that's kind of allowed us to do this, and Fedora's operating much the same way. They've replaced the sys5init daemon with Upstart, but haven't yet replaced their init scripts with Upstart jobs. And there's sort of a description there of some of the changes. There's actually been a major release Upstart since then. Upstart 0.5 came out last year. This was a fairly large rewrite of Upstart, and this was basing it around dbus. The dbus version was sort of the kind of realization that in the plumbing layer, dbus was really becoming the central process. It's now no longer really conceivable that you would have a machine without dbus installed on it. Minimal servers and so on may do, but even in the embedded space, dbus has become the standard daemon for communication between the different parts of an embedded kind of mobile device and so on. So this had a kind of a large effect on the development of Upstart, and I re-engineered it to be based on dbus. So it uses dbus internally between its init control and Upstart, and also all jobs and all properties are available over dbus. There was kind of a controversial feature of 0.5. One of the things I've been trying to work out is how to supervise daemons. Daemon processes have an annoying habit of forking and going off into the background, disconnecting them from the process that runs them. And this is kind of annoying because you can't really supervise them. Now, many other sort of init daemons have kind of said, well, don't fork off into the background. But that doesn't work either, because then you don't know that the daemon's actually running. If you take most servers, they actually don't fork off into the background until they're listening on their well-known port, or they've got their well-known name registered on the bus. And this is very useful because you can use the fork as a notification of readiness. So we kind of wanted to be able to just supervise these. And the kernel doesn't really provide many interfaces for this. Anyone who follows LKML will know I've sent a few patches over the years to try and remedy this. The latest one that is needs to be rewritten again. But Upstart 0.5 has a feature to do this from user space using the ptrace syscall. So it can ptrace daemons and follow their forks and execs, and then shortly tends to hang and crash your machine. It turns out ptrace isn't really that reliable. And then one of the main changes as well that came in 0.5 was this sort of operators for events. So you can say or and in its expressions for syntaxes. But this doesn't work out so well, which I'll go into in a bit. So that's kind of the history of where we went. The other thing about Upstart 0.5 is it's not actually been deployed anywhere yet. We've deliberately not deployed it in Ubuntu because it's not as stable as 0.3. And I know Fedora has deliberately not deployed it because Fedora 11 is going to be the base for RHEL 6. So they don't want a relatively unstable daemon being part of, as a core as the process one on the system. But it's sort of the base for the current and future development. So one of the problems with Upstart, which I kind of want to talk about, is that while we've got the kind of the service manager part of it very stable and very secure, we haven't really got the syntax for defining when services are run very well. In sys5init, it's easy. You just put the init script in a particular directory, RC2 or RC5, depending whether you're using a Debian-based system or a Red Hat-based system. In Upstart, you kind of have to define it using events. And a simple sort of multi-user service that, well, that's not multi-user if you're Red Hat, but a simple service that runs in many run levels would, in Upstart, be defined with something like that. It's kind of a start on run level event, 2, 3, 4, 5, but stop on a run level event, changing the run level to something not 2, 3, 4, 5. So it's kind of, there's lots and lots of problems with that. You can easily get it wrong, you can easily mismatch the two sets of arguments. If you do mismatch the two sets of arguments deliberately, it's often not obvious why you did that. And there's a lot of kind of ways that isn't really the nicest syntax to be able to do it. And that's the simplest possible example. So one of the big changes we're going to be making for Upstart 1.0 is in this kind of syntax. And in Upstart 1.0, the syntax for that will be just while run level 2, 3, 4, 5. You can express that as while run level 2 or run level 3. But it merges the two kind of the syntax lines into one and matches on the run level state. Another example is the single dependency of a service. This would be a service probably much like HAL. It would be a service that's just depended on dbus and need to be running while the dbus daemon is running. And we would, right now you'd have to say it started dbus. Started is an event that the dbus service would emit when it started. It's one of the sort of internal events to Upstart. And you'd have to say stop on stopping dbus, which is an event emitted when dbus is about to be stopped, or has been detected that it's died. Again, there's lots of little problems with this. The difference between started and stopping is not entirely obvious unless OpenOffice throws a kerning error into the slide. If you want to start and stop on different services, again, it's kind of tricky to express. So 1.0 is a much simpler syntax, again, just while dbus. While the dbus daemon is actually running, you want to be run. Upstart has a neat feature. You can insert things as dependencies of other things. An example of this kind of job is Tomcat. If the Tomcat service is installed, it needs to be running while Apache is running as a dependency of Apache. It's something that I don't think there's another init daemon that allows you to do this, but in the Tomcat job, you can actually define it to say that it is running all the time that Apache itself is actually running. If you started Apache, Tomcat would get started automatically and be running before Apache is running. If you stopped Apache or stopped Tomcat, Apache would come back down again. Now, the interesting thing about this is the syntax is very slightly different to the syntax for a normal dependency, quite confusingly so. You actually just reverse the ing and ed on the starting to started to starting, stopping to stopped. And that's not exactly the most and easiest syntax in the world to use. And so 1.0 introduces before. So you just say before Apache. There's actually a slight competition. I'm not entirely convinced before is the right keyword for that, but it suffices for now. You just simply put in Tomcat job before Apache. It has an interesting sort of side effect, which I'll introduce later, but it does make the service you're defining a dependency of the service, Apache. I kind of want to show the difference where, if you're used to the current version of Upstart where the difference runs, jobs kind of have a waiting state and a running state, move from waiting to running when they're started, running to waiting when they're stopped. Starting is submitted when they're moving waiting to running, started when they're at running, stopping emitted, running to waiting, stopped when they're back at waiting again. So you kind of have this four-step process. The starting and stopping events are kind of interesting because they actually block the service. So if you start a service and the starting event has to complete before the service actually starts. So this is what makes the inverse dependency case work. So the while part of the syntax matches when it's actually in the running state, and the before part matches when it's in the waiting state. But again, with the blocking, so a process in before would, if you start processing it has things listed as before, then it waits for those things to be started first. There's also, if you want to define your own kind of pieces, if you wanted something running from when something's starting to stopping, i.e. when something's first started to when it's first stopped, you can do this with from until. It's a kind of easy way to do it. But I don't really know of any reason you'd ever want to do that, but there might be people might want to do that. So this brings us to one of the bugs of 0.5, which is one of the main reasons 0.5 never got really deployed. If you wanted to do a multiple dependency, a dependency on dbus and udiv, this would actually be more like what HAL would look like today. Depends on both dbus and udiv. And udiv and dbus have no interdependency. You might try something like start on started dbus and started udiv. And you might try something like stop on stopping dbus or stopping udiv. So it actually would work. You'd put that on your system, you'd boot up, HAL would wait, dbus and udiv would both be started, then HAL would start, and then when you shut down again, it would look like HAL got stopped first, dbus and udiv got stopped first. The point at which it doesn't work is if you then restarted dbus or restarted udiv. If you actually, with this job, restart dbus, HAL would stop. It would, so it's dropping the thing. Right. HAL would stop. HAL would actually do exactly what you expect. Dbus would start back up again, HAL would not start. And this turned out not just to be just a bug, but it actually turns out to be a a basic problem with the way Upstart was processing events. In fact, the reason HAL wasn't restarted again, it was waiting for UDEV to start. It didn't know that UDEV was already running because it was waiting for an event. It wasn't working on a state. So it would just sit there waiting. If you restarted dbus and UDEV, HAL would restart, but you very, very rarely want to do that. Now, the syntax-wise, 1.0 is obviously exactly what you'd expect here. It does the while dbus and while UDEV. So you get a much easier syntax, but without the bug of having this restart problem. While works on the state. While actually make sure that dbus is not only make sure that dbus is running, it matches the dbus job. Sorry, I have a dry throat. Matches the dbus job inside Upstart. So if you were now to restart dbus, while dbus and UDEV goes false because dbus isn't running, dbus restarts. Dbus becomes true. UDEV has always remained true, so the while condition is again satisfied. So it restarts, which is what we actually wanted to do. And you can combine these in kind of quite interesting ways. So that's a very silly job. It runs while UDEV and before HAL or before device kit and from sunrise to sunset. Although I was writing this and as the silly example, and I realized that there's an interesting side effect to the before, because HAL and device kit now depend on UDEV as a result of this, because you've inserted your job as a dependency of HAL or device kit, and your job depends on UDEV, so now does HAL and device kit, and you can't run either of them at night either because of this. But, yeah, you can create very interesting things. And it actually turned out, as soon as I did this, someone came up with a use case exactly why you would want to do this. So comes up for the battery power status. We'll talk about it in a minute. But you can kind of create very interesting side effects with this, but it works. So I kind of wanted to just go on a kind of basic example of what you might do as a server administrator. So if you've got a job in Upstart North 5, which is run on Apache, run on MySQL, stopped when either of them stops, you would actually, that might be a LAMP job. Now, this is kind of something you can't really do. You want to define a run level, but only a run level for your servers, your LAMP server. So you might define it like this, Apache, MySQL, stops on Apache and MySQL. You'd actually in Upstart North 5 do start LAMP, and it'll tell you LAMP is now running. But annoyingly, neither Apache or MySQL actually are running. And this is because the current versions of Upstart are very much event-based by design. They entirely rely on the knowledge of events and passage of events to process things. And when you started LAMP, you can override it as a system administrator. So when you started LAMP, you started this LAMP service. You, in fact, overrode its start-on condition. So it would actually stop if Apache or MySQL stopped, but it doesn't do anything that makes them start. In fact, to make them start, you'd need to go and edit the Apache and MySQL jobs to put in start-on, starting LAMP, and so on in there. It doesn't quite do what you want it to do at all. So 1.0, a bit more interesting. In our LAMP job, we could put while Apache and MySQL, run while both of those are running. And if you try to start LAMP, cannot start LAMP, it's not running Apache and MySQL. Well, that was the first idea. In fact, that's actually completely wrong. You don't want to do that at all. I tend to think any software which tells the system administrator off for doing something wrong or complains that it can't do something and then gives exact details of what it can't do and why and how to fix the problem is being just annoying. In fact, you actually, if the Upstart can tell you exactly what commands you effectively need to run, and it's just being annoying at you, it's telling you what it won't do itself. So what we actually want to see is LAMP running. We want to see if we've got a job called LAMP defining on Apache and MySQL, then we try and start Apache, try and start LAMP. We want to see it running, and we want to see Apache and MySQL running as a result. This is something that a dependency-based system tends to do very well, but an event-based system doesn't do. And this is something that does work in Upstart 1.0. It works because the while condition works in both directions, basically. If you try and start the LAMP service, it knows the Apache is false, it knows MySQL is false, but it knows that they are Upstart defined jobs. It knows how to start those, so it can start those for you. And so you start LAMP, it brings Apache and MySQL up, but the event of LAMP coming up starts Apache, starts MySQL. And if you were to stop LAMP again subsequently, they would go back down again because the service that brought them up has gone away. There's also most interesting what's the other way up as well. If you started, which is, I've got one. Yeah, if you start Apache and start MySQL without LAMP actually started, it would actually still say LAMP is running. So the system works in both directions. If you started LAMP, it would start MySQL for you, it would start Apache for you. If you start Apache and MySQL separately as a system administrator, the LAMP service would also be running because its conditions to be run are also fulfilled. So you can kind of define little statuses like this. And this has a nice side effect. Run levels now can just go away. You don't need this sort of 2, 3, 4, and 5 with some arbitrary difference. You can define specific states that you want. If you want to have a LAMP state that is when your LAMP service is running, or a customer-facing website state for your customer-facing website and its service dependencies, you just define that as a file called customer-facing website and list in its dependencies. And it works in both directions. If you, as a system administrator, start those individual services, it will say your customer-facing website is running. If you stop customer-facing website, it will also stop those particular services again. So you can kind of get rid of this. You can quite easily get rid of the run level 2, run level 3, run level 4, run level 5, except for backwards compatibility. You can define, we're sort of playing with this, you can define arbitrary states. I mean, the system states start to become easier then if you define them as these just lists of dependencies. You can define a battery state. So the battery state and a power state would define what services could be running when you're on battery power, what services can be running when you're on AC power. And to make a service not run on battery power, you simply omit it from the battery state. And then when you switch from battery to power, the dependency goes away and the service would stop. So if you didn't want your database server running on battery, you only have it listed in AC power. And then the AC power and battery power objects can themselves depend on network and hardware and all sorts of similar things. So other things coming into Upstart 1.0 are some changes since the way that events work. Events kind of get used in various ways. For what started off as just a simple string and grew arguments and environments as it went along, it turns out you can do a lot with them. So you have sort of events like signal events. These signal that something has occurred. That's all they do. They signal it has occurred. You don't have to remember it occurred afterwards. It's a transitory event. The typical example of this is the Control-Alt-Delete key. The kernel sends a signal to it. In the case of Upstart, emits this as an Upstart event and allows you to hook onto it. So every time you press Control-Alt-Delete, you get a Control-Alt-Delete event. Now, the interesting thing about these is you don't really care has the user pressed Control-Alt-Delete at some point in the past. You want to do something when it's pressed. So you can define quite a simple Upstart 1.0 job there. It's running while multi-user is a kind of a run level state there, so just talking about, and just on Control-Alt-Delete. So while you're in the multi-user state, if Control-Alt-Delete is pressed, it would go arg to wall, so beep all the users. More interesting, if you just keep holding down Control-Delete, you'd get incrementally more and more wall messages. It wouldn't stop the first time it's run. And you might get overlapping wall messages if you manage to get it really fast. Each individual Control-Delete press spawns a new one of these. So if you ran debus daemon when you on Control-Delete and had on Control-Delete, you'd get a lot of debus daemons. So don't do that. Another type of event we tend to get used. This relies on the property that when you ask Upstart to emit an event on your behalf, it doesn't reply to say that the event is complete until services have been stopped, until any tasks have completed that are run on these events. And then this allows many daemons to use Upstart as a dispatch daemon. Network Manager can say the interface is up. Upstart will then respond when any changes to the system as a result of the interface coming up are complete. ACPD is another example here. It right now has a .d directory that runs various shell scripts. You can quite trivially turn that into an Upstart event and have those shell scripts inside Upstart's configurations instead. And then you can you want to know about the completion of these. Rather than Control-Delete, you don't really care that the event's completed. It's just run every time Control-Delete is pressed. These, the ACPD is probably emitting the suspend event into Upstart. It's waiting, Upstart runs various shell scripts, various tasks. It might stop services, it might start services. They're quite a way to want to start service suspend. Boot chart, that's why you want to start service suspend. It will start and stop services, and then it reports to ACPD when all of the side effects of the suspend event are complete, and then that allows ACPD to take further action. In fact, I think in this case, ACPD doesn't do much more now than run the scripts, but your reboots and shutdown are typical examples of these kind of events. You run reboot from the reboot command, it sets reboot into Upstart, does a whole bunch of processing. When Upstart comes back and says the reboot effects have been completed, the reboot command actually calls the reboot syscall. So that's sort of how you use hook events. And then you kind of have these state change events, which indicate that a service has changed state, or a network card has changed state, or something else. And probably one of the biggest changes again in 1.0 is that these got reversed from 0.5. So what used to be stopping PostgreSQL changed back to PostgreSQL stopping, which was how it was before. So one of my biggest complaints I always get about Upstart is that it's not very well documented. It's not very well documented because I change things too often. It's still 0.0, so we've still never deliberately asked people to move over to Upstart jobs because we kind of want to get things right first. So this allows you to, for example, in this case, when the PostgreSQL server stops, and has a failed result. Failed means that the daemon crashed. You can obtain the reason the daemon crashed in exit signal or exit status. You actually want to run some other command. You might want to back up your database, you might want to grep for logs, you might want to vacuum it, restore a backup, who knows. But it allows you to run things when other things change state. And again, if PostgreSQL was repeatedly stopping, you'd get multiple copies of the script running. So you can kind of do other things as well. You can do this when something starts. So you could have on exim starting do some script which it maybe delivers failed, previously held messages and so on. Will be on started. But again, that's not the difference between that and doing this as while exim is that if exim was to stop, your script keeps running, which may or may not be what you want. But if it's not what you want, use while instead of on. Kind of the difference between the two of them. Another one of these sort of things we're going to finally introduce. We've been talking about it for quite a long time. We've kind of been talking about it because it's never been clear it's what we actually want to do or not. But I've taken the decision that it is what I want to do, which is to replace cron and attd properly. At the moment, we've been just kind of leaving cron and attd running and not integrating with Upstart. We considered integrating them with Upstart to, so they used Upstart services on timers, but we've now made the decision that actually they're going to go away, and the init daemon itself will run these features. There turns out to be a lot of good reasons why you would want to get rid of these two daemons and fold them into init. The behavior, while it doesn't seem to overlap initially, when you actually look at it, cron has behaviors you want init to have, and init has behaviors that you want cron to have. So, they're timed events. You'll get is there's sort of a daily, hourly, weekly, monthly kind of event that Upstart will generate. So you would be able to sort of have something run daily. Just an Upstart job would say daily, script, whatever. You can have specific time events. The syntax for that isn't quite worked out yet, but you can, for example, at 8 p.m. is a good example. If you want something run daily at 8 p.m., you just say that. You've got at-like behavior as well. The in 2 hours kind of behavior. I want this to run in 2 hours' time. Every 2 hours, step-like behavior, repeat behavior. You can also then start offsetting events from each other. And this is where the at-like behavior you want in Upstart. you want to be able to say in init, I want to run something 45 seconds after startup. You don't want to run it at startup, you don't want to run it in the boot sequence, but 45 seconds later might be about right. And you might, assumably you run very IO niced and very nice, so your whatever process you're running doesn't take up any particular user CPU. And you can combine them with other while states, like every 10 minutes while a network device is up, you want to run a state over and over, an event, a job over and over again. So you can kind of do a build up on these. When I talk about cron, there's overlap. Cron has, for example, an @reboot command, which is on boot, and cron also sends mails on failure and on bad return codes. Well, it would be really nice, I think, if init sent you a mail with Apache's output when Apache crashes. So I think there's a lot of overlap between those two daemons. Just going to quickly jump through actions here. This is this sort of less well-defined. Is an action would be, for example, you want to be able to support reloading the syslog daemons. So when you go start syslog reload, you want it to send a hop to the master daemon. You want to be able to execute another process. So you want to be able to do an Apache graceful, would send Apache to -k graceful when you run that. These are defined inside the Apache job file. You might want to have a rotate logs kind of sub-job action, and that's run daily. So you can define cron events inside the same file that defines your service. And you can define, for example, a remote sync subdaemon which runs while there's a network device. So you can have a daemon running. When there's a network device up, you start up a second daemon that runs and pairs with it. You can actually have them unattached. So right now, those can only run when the parent daemon is running. Unattached actions can run at any time. So even if Apache stopped, Apache backup or Apache test config would still work. And you can even define completely separate services in this manner. There's an argument whether Samba should be defined as two jobs, SMBD or NMBD, or just one job with two sort of SMBD and NMBD blocks inside it. So because they're sufficiently related. So that's kind of the actions. I just jumped over that quickly, but it's not well defined enough yet. But plan. Upstart 0.5x. This plans to do very rapid releases, at least monthly from now until 1.0 is ready, maybe even weekly if there's particular things land quick enough. So 0.5.1 was released a couple of weeks ago, and this is a feature identical to 0.5.0, but it has some major code base improvements. And these will, starting to bring in the code base improvements to do the further development. 0.5.2 is intended to arrive this month, and that brings some major changes to the dbus API, allowing you to get sort of various properties on the objects you can't get right now. Then there's 0.5.3 and so on planned after that with whatever changes occur. There's no particular full kind of list of changes that in a particular order. We're just developing them as and when. Upstart 0.10 will be the first with the new job syntax, and I kind of expect that around June 2009, so there'll probably be 4 or 5 releases of Upstart 0.5 before then. And then we'll switch to a 0.10 development series for bugs and everything that comes up. And this is intended to arrive in the next version of Ubuntu. So we'll see that if you want to sort of play with this version and stuff, you just use what's going to be Ubuntu Karmic. So you can use that, and I suspect Fedora 12 will probably pick that up as well in its development process. And then Upstart 1.0, the current target release date is for the Linux Plumbers Conference in September. That's in Portland. And if I wimp out before then and decide it's not 1.0 because it's not feature complete, it might be declared 0.5, but I doubt that. But so a lot of these features should be ready in time for plumbers later this year. Okay, so that's my quick sort of tour. So just any Q&A? We've got about 5 minutes left. So yes.
You said something about new job syntax. Would it be easier to get integrated in the distribution
If sorry, I didn't catch the last bit. So the question there, would it be easier to get it integrated into the distributions if we didn't keep futzing with the syntax? Yes, probably. It's one of the reasons that there's not much documentation on the current syntax is because we recommend that any distribution that wants to pick it up doesn't deploy Upstart jobs just yet, and that they only kind of they stay up very close to upstream, and we do it as step releases. This does cause some problems because there are some distributions which aren't yet happy to deploy it because it might change. Especially causes some problems when some upstreams want to be able to ship Upstart job files and they come to me to find out how and I tell them not to. It would probably be easier, but at the same time, it's release early and release often. If we stuck the job syntax in stone when we did 0.1, then we would right now have something that didn't work. So it seems better to release it early when it's in 0. It's still an alpha really. It's test code, it's beta code, alpha code. When we actually declare a beta release later on, or even a final 1.0, then the job syntax will be in stone. So it's it would be easy to get it integrated, yes, but it would be much harder to develop it and get it right if the job syntax was stayed in stone all the time. But yeah, once Upstart 1.0, the intent is that is a defined job syntax that will be documented, and that won't change then. If it changes after that, it will be Upstart 2.0, a major rev, so to make it obvious. Yep.
How does this determine the state started?
Sorry, how's that?
If the state started already determines if you have a Tomcat completely started before Apache, it may need some time for imaging until it gets up the listening point.
So
You start the Apache before that happens, but you already thought that Tomcat.
right. So there's a question there. How do you know? So if you start Tomcat, how do you know that Tomcat is running before you start Apache? Is that the question? What do you say?
It's the point where it decided to see the state started of Tomcat.
Right. So how do you know when Tomcat isn't really starting? It's actually started that it can be used by Apache. Is it? Yeah. Assuming sort of go there. Most daemons, most services aren't ready when you just run the process. They need to listen, they need to set up some state, they need to have a socket open, or they need to connect to something. How do you know they're actually running? There's various tricks. First of all, many of them, if they demonize, don't demonize until after they've done all this. It allows for, it's a very good, there seems to be two thoughts, but most processes don't do this because then it allows them to report errors if they have problems. So this is one reason why I've been very keen to get tracking of demonizing processes working, because then you just tell Tomcat it can fork off into the background, it can be a daemon, and it won't do that until it's actually ready to be run. Otherwise, if you ran Tomcat semicolon Apache, that wouldn't work either. You can look for a socket, so you can actually do listen monitoring. When it's actually listening on a port, you can do that. Tomcat might set the socket up before it's ready, but it's not going to be calling accept till it's ready, so anything connecting would block anyway. In the case of dbus services and other parts of the plumbing, you can wait for dbus names. So you can say expect dbus name, and you can then wait for it again to publish its name on the bus. It might not be ready, but it's not going to be accepting and processing dbus messages till it is ready, so you can go get away with that. Many processes might not be fully united, but they're, fortunately most syscalls tend to block, so it's not so much of a problem. Okay. We've got time for maybe one more question? Yes, Daniel.
You said that you wanted to kind of replace that with Chrome.
Yes.
How do you intend to do user partitioning so that individual system users can actually set jobs up?
So question there, if we replace that in cron, how do we tend to do user partitioning so you can set up cron jobs up as a normal user? It's actually relatively easy. We're actually going to allow users to do any kind of job and service. We allow users to define their own services. The users can define their own Apache jobs, their own anything else, provided they've got permission to run those. It doesn't run them as root, it runs them as the user. The dbus tells us the username of somebody making a user request. PolicyKit tells us whether they're authorized to make that request, so we can provide very simple authorizations for jobs. So there is probably most likely there'll be a .init directory and users' home directories, or a valspool init, either one of the two. Both have advantages and disadvantages, and anything in there is run as that user. So
So you'd be relying on PolicyKit, for example, to prevent a user process from emitting control of delete events?
true, yes, exactly the point. We would prevent, PolicyKit's there to prevent a user from emitting a control delete event. And if the user was authorized to do it, the control delete event only, so if PolicyKit allows you to breach the user barrier, if a user emits a control delete event, they're allowed to do that. However, it would only start and stop their services. However, if they're defined by policy kit, that control delete event could start and stop user root services as well. So that allows us to have non-privileged parts of the system sending events to privileged parts of the system. So it doesn't deauthorize it, it doesn't refuse it, it just only affects your services. So you can muck around with your own services. It doesn't then it doesn't let you do anything that you couldn't do with a shell anyway. So yeah. Okay, I think that's all I've got time for. So thank you very much.